Okay guys, it's after Eagle Fest, so I probably look a little rough, but I promised you guys I would get some videos up. So I'm going to do both 0, 4 lessons. Basically, it's just simplifying radical expressions. You've done this forever. So we'll just go over it really, really fast. Hopefully the videos will be pretty short. So first thing we're going to do is simplify expressions in radical form. Okay, this is directly from your book, so if you want to read it. Simplifying radicals, a square root of a number is one of 2 equal factors of that number. So it's the opposite of a square. So like if you have 5 squared, you get 25. But if you have the square root of 25, you have 5, because the 2 factors are 5. For example, here we go. 4 is the square root of 16, because 4 times 4, or 4 squared is 16. So, in general, if A and B are real numbers, so we're going to deal with real numbers, no imaginary, and n is a positive integers greater than 1, then b to the n equals a. Hence, it's the root. I'll let you read these principles from your book and stuff, but you're gonna get it pretty fast. Okay, this is what the radical expression looks like. You have the radical, a. Now inside is the root. If there's no number, it's a square, but then you might have a 3, so it's a cube root, a 4, the 4th root, 5th root, and so on. So here we go. If a is greater than 0, you're going to have positive roots. Oh, sorry. If this is an n is even, this is an n is odd. So we're going to do even first. If a is greater than 0, you're going to have 1 positive root and 1 negative root. Okay, so plus or minus. If it's less than 0, you're going to have absolutely no real roots. That's where the imaginary numbers come in. So no imaginary numbers for this episode. And if a equals 0, so if it's 0, the answer is just 0. Now if n is odd, so 1, 3, well not 1, 3, 5, 7, 9, and so on, 1 positive and 0 negatives. If a is less than 0, so basically if a is negative, it is allowed. And if you have 0 underneath the radical, it's 0. So let's work on some problems. Okay, so here are some very big examples here. You got negative square root of 81. Well, the negative is negative. So square root of 81, well, the factors are 9 and 9, and since it's a square root, you need 2 factors. So 9 and 9. So that's the circle, circle, kill. So the answer is negative 9. Okay, we have the 4th root of 16 and 625. So if you remember your rules on radicals, you have the 4th root of 16 over the 4th root of 625. Alright, so let's do the 16 first. Now the 4th root means I need 4 factors of the same number, so that breaks down to 4 and 4, right? And the 4 breaks down to 2 and 2. So I have 1, 2, 3, 4. I have 4 2's, and so it's a 4th root. I need 4 factors of the same number. So if you want circle, 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 kill, kill, kill. So the numerator is 2. Okay. The denominator, again, this is 25 and 25. 5 and 5. 5 and 5. So the 4 factors are 5. Get all rid of them all. So the answer is 2 over 5. Okay? This one is an even root again, but it has a negative underneath. So if it's an even root with a negative over it, so the answer is no real solution. So NRS is fine. Now, if it was an odd, then we'd actually been able to do it. Okay, so basic properties is one I kind of already did. You can multiply if it's the same root. You can divide if it's the same root. If it's different roots, like a square root and a cube root, you cannot combine those. Okay, so here's 4 examples. Now this is going to be pretty easy for you. I'll show you kind of 2 different ways to do this. The first way is kind of a long way to do it, but this is an 8, so I need 8 of the same factor. So here's 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 8 of the same factor. 2, 3, 4, 6. Okay, there's another 8. And there's the other 8, okay? So I actually have 3 sets of 8 B's. So you just need one B from each of those sets. So the answer is B to the third. Now, easy way to do it, 24 divided by 8 is 3, so B to the third. We're going to go to this one now. Okay, it's the sixth root. So we need to figure out, the factor of, a factor of 6. So 64, you have 8 and 8, 4 and 2, there's 4 and 2. Here's 2, 2, 2, 2, 2, and 2. So I actually have 6 2's, which I needed. Then you have this 2. So I'm not going to write it out, but y plus 2, y plus 2, y plus 2. You're going to put that down 30 times if you want. So here's my 6 2's. You can do the circle, kill thing if you want. So I have 1, 2 left. We get there? And then 30 divided by 6 is 5. So y plus 2 to the 5th. And there's your answer there. Up here we got the square root. So we have 8 and 6, 2 and 4, 2 and 2, and 2 and 3. So since it's square root, I need factors of 2. 1, 2, circle, circle, kill, circle, circle, kill. Now I also have x to the 5th. You can put 5 x's, do the same thing down, or you can make it really simple. So I have 2 2's, so this is 4. I have the 3, that goes on the inside. Now I have the x. So you can kind of do it. How many times can 2 go to 5? Or what's 5 divided by 2? Well, that's 2 with 1 extra. So x squared, and then 1 x remains. And there's that answer. All right, last one. You have the cube root of negative 27, a to the 6th, b to the 3rd, c to the 5th. So we're going to make it really simple. Negative is allowed because it is an odd factor, so negative. Okay, 27. 27 breaks down to 9 and 3. 3 and 3. So I need a 3. There's 2's gone, so a 3 is on the outside. The rest of it is pretty simple. 6 divided by 3 is 2. So I get a squared on the outside. 3 divided by 3 is 1, so I still need to put b. 5 divided by 3, well, it's not going to be perfect, so 3 can go in the 5 once, so there's a c on the outside. And then here's my cube root, and I have c squared left over because I took 3 away and there's still 2 left. Okay, if you have any questions, ask in the classroom. But your assignment was page P17, 1 through 16. Try showing as much work as you can. If you have any questions, please ask.